a sum of cubes, then I have to prepare a, the trinomial is here. I have to focus on the binomial first, because here's why. It's not a mistake, right? Because I can write a trinomial times the binomial, doesn't matter. However, if I don't determine the binomial, I would have difficulties finding the trinomial. The binomial tells me what I have to write in the trinomial. So that's the key. Well, actually, your question, I had, in 22 years of teaching, I've never said that first. By you saying what you said, I realized that, well, duh, I should have always mentioned that the binomial has to be written first, not because it's wrong to put the trinomial first and the binomial second, but because without, I did say that always, without the binomial, you cannot figure out the trinomial. Okay, that part I said. But the fact that we have to determine and put it first, I didn't say it. Okay, so I need to find something that I cube to get y cubed, and that will be my first term in the binomial. And maybe we should talk about the sequence of signs first so we don't mess up.
Negative.
Exactly. And the last one, we don't even discuss it. It's always positive. So now please tell me what cubed is y cubed? Y cubed is y cubed. That's why we studied all those power rules and so on and so forth in chapter 5. Okay, so now?
Could be 2.
It cannot be anything but 2.
Okay.
Because only 2 cubed is 8. There's nothing else. Now, let's think about the pattern here. The pattern here is what I taught you before in chapter 5, but without the 2 in front and the middle. Same pattern, but it's different formula, different product. Right. So the first term squared minus just the product of these two and plus the second term squared. So tell me what should I put in the trinomial? First term squared.
Y squared.
Perfect. The product.
Minus 2.
Good. Plus the second term squared.
2.
Squared.
2 squared.
I can't write 2 squared. I have to write 4. Any questions?
This one.
Oh, we're going to do a lot more than just another one. But here's the question. What if I'm not sure about this? What would I do? Distribute, right? I will just multiply. Okay, let's multiply. Let's multiply. Y times y squared, y times negative 2y, y times 4, 2 times this, 2 times this, 2 times this, and tell me whether you get y cubed plus 8. Let's do it. So right, check. I want to check my work. So please dictate. I'm sorry? Yes, I just want to check.
Y times y squared is y to the third.
Good.
And then y times...
I have to write the symbol first.
Minus y times 2y, which would be y, right?
Y times 2y is 2y squared.
Okay.
Then?
So plus 4y plus 2y squared minus 4y plus 8.
Good. So let's see. Do 4 terms go away and I get y cubed plus 8? If I don't, something is wrong.
Yep.
We see the negative 4y with a positive 4y. Gone. We see the positive 2y squared with a negative 2y squared. Gone. And we get back the starting point, which means this factored form is correct. It represents y cubed plus 8. And again, why are we doing this? It's because this one has no applications. This one does. Now and in the future, you'll see.
So earlier you mentioned you couldn't do 2 squared. Is that because
The
it wouldn't-
sum,
This
not the cube. The sum of squares, not the sum of cubes.
Okay.
We have written formulas for the sum of cubes. Here's this formula for the sum of cubes.
Yeah, I'm just confused because the formula ends with b squared at the end, but you can't write b squared on the end of the other one that you just did.
Here,
Right. You have to write 4 instead.
but for the same thing, I don't write y in parentheses squared here. I have to write y squared. I have to get it simplified. If I write 2 squared, it's not wrong, but then I have to go back and simplify it and change it to 4.
Right, that's what I was asking. The only reason why you're doing that is because you've got to simplify it, right?
Yes.
So, for example, if the problem that you just gave to us was y3 plus b3, you wouldn't do, then it
I would
wouldn't be,
write b squared.
it wouldn't be b squared at the end because you don't know what b is.
Right, exactly.
Okay.
But
that's
here,
all I'm
because
asking.
it's 2 squared, I have to write 4.
Right, because it's got to be fully factored.
If I write 2, no, because it has to be simplified.
Okay.
But you're correct. I have to write x squared, but I would not write 2 squared.
Right, got you, because you know what 2 is. Okay.
Right, so you can write 2 squared, but then you have to write equals and write one more line in which you replace 2 squared by 4.
Okay.
Which is fine, acceptable.
All right.
You don't have to do it in one step. Okay, any questions here? Okay, next. Um, 1 over 27 minus x cubed. I know you're anxious to get to the bottom, but please let's go through step by step. What type of polynomial is this? I know you're saying, but this is redundant now. You only taught us binomials. What can it be? It must be a binomial, true. But when everything will be put in the same basket, that will be a very valid question. So what type of polynomial is this?
is
Good. Greatest common factor, I'm sorry, is it in descending order?
No?
No, so please dictate.
x negative.
Yes, the terms are taken with the sum symbol in front. I cannot separate x cubed from -1.
Plus
Yes,
1 over 24.
awesome. Greatest common factor. Do these two terms have a common factor? No. Negative leading coefficient.
Yes.
Yes.
I have to pull it out.
What does that mean?
Very good. If they have a common factor, I will pull out the common factor and the -1 in front. If they don't have a common factor, I will only pull out -1.
So you're removing the negative sign?
I'm factoring out -1.
Okay.
I can factor out anything I want from anything I want. For example, so this is a side thing. We're not finished here. Let's say I have x squared plus 5x, and I want to pull out 100. You could say that's insane. These two terms don't have 100 in common. You don't have a common factor of 100. Where did it come up with 100? I want to factor out 100. As long as I put the correct quantities in here, I can factor out anything I decide to factor. 100 over 1 times x squared over 100 is x squared. 100 over 1 times 5x over 100 is 5x. So if I decide to factor out x cubed, you can say there is no common factor of x cubed, and I would have to agree. But I decide to factor out x cubed. As long as the quantity in parentheses times x cubed gives me this, I'm allowed to. It makes no sense to factor out x cubed here. But I just want to show you that I can factor out anything I can think of, because x cubed over 1 times 1 over x is x squared. X cubed over 1 times 5 over x squared is 5x. So I'm allowed to factor out -1, and this time I have to factor out -1. Even if -1 is not a common factor to both, it's a negative leading coefficient. And you will see later on why this is so important. Okay? So these were just some examples. They have no meaning other than the fact that I can factor on anything. Because I'm not going to factor on here 100, ever. And I'm not going to factor on here x cubed, there's no need. But I can. As long as when I distribute it back, I recover this, I'm fine. As long as I distribute 100 back and I recover this, the two sides are the same. So let's factor on -1. As long as what you write in here gives us this back, we're fine. -1 times blah is negative x cubed. What is blah?
X to the second? No, 3.
Good. Does it make sense? Yes. -1 times x cubed is negative x cubed. Perfect. Then,
Plus
-1 times +1 will not be +1.
negative.
Ah. As in my silly examples here, as long as this times this is this and this times this is this, I'm fine.
1 over 27.
Let's take a moment and check. Is -1 times x cubed negative x cubed?
Yes.
Is -1 times -1 over 27 +1 over 27? We're safe. Now I continue with my list. I'm here now. I have 4 options to think of. Does one of them have to be applicable here? No. No. I'm hoping for a special product. If there is no special product, then I'm done. If I cannot apply any of this, then I'm done if I apply this too, right? I'll say not factorable. This is it. So because there is a difference inside, I exclude this and I exclude this. So I'm really looking at these two. All I have to do now is identify whether the terms are perfect squares or perfect cubes.
Difference of perfect cube.
Once you say that, then I should prepare what?
3.
I should prepare a,
By
yes?
try.
Awesome. You should always put those parentheses so it reminds you of the next step. So put the parentheses and now let's identify the binomial first. Let's go to the sequence of signs. If we are factoring the difference of cubes, the binomial must have,
Plus
the binomial always follows, yes,
and a plus.
and a plus. Awesome. So now I have to identify what quantity I cubed to get x cubed. What could that be?
X cubed. Oh no.
So remember this is a cubed. This cannot be a cubed. So this must be the quantity that I cube to get x cubed.
Yeah.
It has to be x. Now, what quantity I cube to get this one?
One over.
Yes,
No, 7.
3.
Wait, I'm confused.
You're right. 1 over 3 times 1 over 3 times 1 over 3 is 1 over 27. 3 cubed is 27. Good. Now the trinomial has a pattern. First term.
X squared.
Perfect. The middle one. That's why I emphasize put the sequence of signs first, because now you may be tempted to say x times -1/3 is -1/3 and change this into negative. Don't. We already established the signs. Thank you. Plus. Thank you. Is this clear? the first term squared, plus the product of those terms. Without that 2 from a different formula has nothing to do with it here. So x times 1/3 is 1/3 x, and then 1/3 squared, which is 1/3 over times 1/3, which is 1/9. Any questions? Okay, let's look at x squared plus 16. What type of polynomial is this? Binomial. Is it in descending order?
Yes.
Greatest common factor? In both?
No.
No. Negative leading coefficient?
Yes. No.
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 And now I'm hoping for a special product. Which one?
It's the sum of squares.
And what do I write?
2 factors. 2 factors. 2 points. I don't know how it's.
You can't factor it.
Oh my god.
Because it's the sum of squares. Your book says, which I don't really like, it says prime. So it may ask you in my labs class to put prime or something. So keep that in mind. It's not factor or prime. Okay. It's a sum of squares. There is nothing you can find that you can multiply to get x squared plus 16. If you say x plus 4 times x plus 4, it has 3 terms, as we learned a long time ago. If you say x plus 4 times x minus 4, will be x squared minus 16. So there is no formula for this. Okay, one more and we move on to trinomials. 4z squared minus 25. What type of polynomial is this?
Right.
Mm-hmm.
4c squared.
Yeah, that's one term.
Yeah.
And minus 25 is the second term.
Oh, bye.
Good. Descending order?
Yes.
Greatest common factor?
Yes.
4 and 25, no. Negative leading coefficient? No. So, special products. Which one? If one is applicable.
Difference of squares.
Right. When you say difference of squares, what will you prepare?
A bi and a tri.
That's for the difference of cubes.
Just 2 binomials.
2 binomials. Good. So what do I square to get 4z squared?
Put a plus and a minus.
Okay, that's good. I agree. So we don't forget. Okay, well, awesome.
You do 4z in the first parenthesis, right?
Careful. I need the quantity that I square to get 4z squared. 2z plus 5, 2z minus 5. Is that clear? Very good. Moving on to trinomials. Yes, it's a lot of work.
A lot of practice too.
This is the most difficult of the 3. The last one is the easiest. The first one is second easiest. This is the most difficult of all. First, questions are identical. 1, 2, 3, 4 are identical. I'm not going to write them again. Number 5, special products. So identical. Trinomials have only 2 special products. How many have binomials? 4. Okay, good. Woody, do you have this handout? Oh, you do. The whole thing, right? Okay. Good. Special products. There are only 2. Ready? We'll come back to that in a second. 6 and 7 This is the end of the strategy for trinomials. But I want to discuss this. So a squared plus 2ab plus b squared. Have we ever seen this before? Aha, he's going back to his notes.
Yeah.
Yes, we have seen this before. We've been using it in chapter 5. So can anyone tell us where it's coming from? What is this?
Special products?
Yes. Which one? So what do I write for the first one? So what do I write?
Let me see the question again.
What do I write on the right-hand side, please?
I don't understand what the question means.
Exactly as we had it here, right?
Yeah.
That's how we refreshed our memory today, the first thing. And then we got here, and I said, okay, how do I factor this? And we established that it was the product of two binomials, a plus b, a minus b. And now I want this and this.
So are we solving the question or?
So I want to factor this. How do I factor it?
Got it.
How do I factor this? That does it. See how important this is? Okay, good. Okay, so let's start.
Oh, wait, okay.
Ready? Here's the first one that we want to factor. It's from the handout, page 3. Okay, what type of polynomial is this? So, okay, one more time, sorry. The trinomial, as you see the summary. What is it? Descending order, greatest common factor, negative leading coefficient, special product. No special product. We need time to get to that. So we're not ready yet. This is not the case here yet. Okay, good. So, what type of polynomial is this?
The chart.
Correct. Is it in descending order?
Yes.
No.
No. So, let's rearrange it. Dictate, please. See why I tortured you with descending order in chapter 5. And identify the leading coefficient and the leading term.
But the leading coefficient is y squared.
No, the term is y squared. The leading coefficient is?
2.
The leading coefficient is?
1.
1. Perfect.
Got it.
Minus 22y plus 121.
Very good. So I accomplished my first 4 steps. Now I am hoping that one of these is applicable. I don't know. If it's not applicable, then I go to this or maybe this. I'll explain later. Okay, so if one of the 2 special products is applicable, which of these 2 specifically I will look at? The first or the second?
It's the second one.
Right, because the middle coefficient is negative. there's nothing I can do with the first one.
Right.
So if the middle coefficient is negative, then I expect the middle coefficient to be negative in the binomial squared. If this works, I don't know yet. I don't know yet. I'm hoping that this is the case. If it's not a special product, then I have to go to try this, or maybe this. Well, this because it's a 1. Okay, so I'm thinking, since the middle term is negative, what sign again do I have to have here?
Positive.
Negative.
Right? If this is negative, this must be negative.
Right.
If that is positive, this must be positive.
Right.
So one more time, if
Right. Negative.
correct. Good. So now I'm thinking, like we did before with the sum and the difference and the sum and difference of cubes and so on and so forth. What squared is y squared?
Why?
What squared is 121? It's 11. Notice one thing, that I have not mentioned anything about what. And I haven't even looked at, I even covered it, I haven't looked at what.
Like my favorite?
The middle term. The middle term, right? So I only said, what squared is this? What squared is this? But I haven't looked at the middle term. What should the middle term be of this expansion? Do not look at to the left. What should the middle term here be? Because we know the formula or the special product from chapter 5. For times 2. First term squared minus 2 times the first times the second minus 22y plus the second term squared. If this is not negative 22y, this does not factor into that. One more time. The formula was learned in chapter 5. So if I see this, in my head I have the first term squared, y squared, minus 2 times the first times the second, which is minus 22y, plus 121, 11 squared. Is that clear? So these two would be identical only if this term is exactly what?
Negative.
2 times 11 times y, which is negative 22y.
Oh,
Is it negative 22y?
yeah.
So this is the correct form.
Can you say that again?
Yes. Let me say it with one other example, and we'll come back and I'll say it again for that one. So let's say I have y squared plus 5y plus 36. Is this a trinomial? It is a trinomial. I covered the middle term.
Well, you covered the term up, so it's a binomial.
Oh god.
You get away with it. Okay, is it a trinomial?
Yes.
Okay, is it in descending order?
Yes.
Negative leading coefficient. Okay. Special product. Greatest common factor. No. Special product.
Yes.
Yes. Right? So I expect, looking at y squared and looking at 36, I expect this. What? What is my expectation here? Yes, yes, positive, correct, because this is positive. And what should I have here?
6.
Right. But now let's think for a moment. When I expand this, when I raise a binomial to the second power, how many terms do I get? Exactly 3. So remember the formula. The first term squared, y squared, plus,
2ab.
yes, 2 times the first times the second. So 2 times y times 6. How much is that?
12y.
Yes. If I don't have 12y here, can I say that this equals that?
No.
Do I have 12y? So this is incorrect. That's what I was doing there.
So if you get a question like that, like what do you put as the answer?
Prime.
Just prime?
I don't like prime, just like not factorable.
It's not factorable. Would you accept either, obviously?
Yes, of course. Okay. Next example. X squared minus 4x plus 4. What type of polynomial is this? Descending order?
Yes.
Greatest common factor? To all three now?
No.
To absolutely all three. Negative leading coefficient? Special product? I hope. I hope for a special product. What will the special product be? The one that you hope for?
Minus
Everything squared. Good. Now, how did I obtain x and 2? Simply by looking at the first term and the last term. But this is not sufficient. The point I'm making here is that I must check the middle term, which I haven't even looked at. I covered it from the beginning, right? So here, knowing the formula from chapter 5, what would be the middle term? A minus, of course,
2
times the first times the second. 2 times x times 2. What is that? 4x. If this is not 4x, this is the incorrect factor form. I have to delete it. Do I have a 4x in there? A squared plus 6a plus 9. So then this is the correct factored form. What type of polynomial is this? Descending order?
Yes.
All three have a common factor? Negative leading coefficient? Special product?
Yeah.
Bless you. I hope for a special product. If it doesn't work, it's going to be more difficult. Special product is easy. What do you expect? Or hope for?
A minus 9 squared.
A
A plus 9 squared.
If I put 9 and square, then this will be 81.
3.
Is that clear?
Yeah.
Good. It works only if the middle term of this expansion is the same with the middle term over there. What is the middle term here? 2 times a times 3. How much is 2 times a times 3?
2 times A times
6a. Is the middle term 6a?
Yes.
So this is the correct form. Okay, one more. Negative 3x squared minus 12x minus 12. Yes, I know you got it, but remember, practicing is like 10 times more.
Yeah.
Okay, what type of polynomial is this?
Trinomial.
I know I sound like a broken record, don't tell me. Descending order,
Yes.
negative leading coefficient, and greatest common factor.
No common factor. Negative.
So there is a common factor in all three, and there is a negative leading coefficient. So what do I pull up? Very good. How many terms? If I pull out negative 3, how many terms do I have to pull it out from? 3 terms. How many terms will I have in parentheses, left in parentheses? Absolutely, otherwise I can't recover them. So please tell me what is left in parentheses. Yes. If I put minus, when I distribute, I get positive. Good.
Plus.
Good. Let's check. Negative 3 times x squared, correct. Negative 3 times 4x, correct. Negative 3 times 4, correct. Now I'm looking inside. I hope for a special product because that's my next step in my strategy. I can't skip this. That's why this is number 5. And then if this doesn't work, then I go to 6 and 7. Okay, so what do you expect? Or hope for? Everything squared. It works only if the middle term of this expansion equals the middle term of this. If it isn't, then I have to stop and delete this. What is the middle term here?
X plus 2.
The middle term. 2 times the first times the second.
4x.
Is it 4x? We agree with 4x here? As the middle term? Okay, is this 4x?
Yes.
Good, so that's the factor form.
Can you write it 2 times
2 times the first times the second. Yes, you can write it on the side somewhere just to show that you checked. Ready? Next one. X squared minus 20 minus x. What type of polynomial is this?
to try?
Trinomial, is it in descending order?
Yes. It is. S squared.
X squared, no x, and no x. Is it in descending order?
Factor about their powers. No, it's not in descending order.
So x squared,
Minus x, yeah.
Oh,
good. Greatest common factor in all three. Negative leading coefficient? No. Special product?
maybe.
Maybe.
No. Why? The last term is negative. There is no last term negative in the trinomial. We do have 2 in binomials. A squared minus b squared. The last term is negative. And we have a cube minus b cubed in binomials, but not in trinomials. So a special product is not applicable here. I'm coming back to my strategy. I went through the first 4. I asked myself if it's a special product. No, this is not a special product. And now I'm checking whether I apply strategy 6 or strategy 7. Okay? So let's compare. If the leading coefficient is 1, then I will be using this strategy. If the leading coefficient is specifically not 1, then I will be using the 7th strategy. Is it 6 or 7? It's 6. Here's the strategy for 6, when a special product is not applicable. Okay?
I didn't write the strategy for
Oh, we didn't write anything other than this.
okay, let me write it.
Yes, Whitney?
So we get that these memorized.
Absolutely. Yep. So that's what it is. This is a summary. So when a trinomial cannot be factored using a special product, then we try this or this.
But
If, go ahead, go ahead, go ahead.
But how can you try that? Because
I haven't explained it yet.
because the last term is a plus sign.
I haven't explained it yet. It's a different strategy. It's not a special product.
Okay.
So I have not explained it yet. I'm doing it right now.
Okay.
So if the leading coefficient is 1 and special products do not work and the leading coefficient is 1, we are going to apply the strategy that I'm showing now. If the leading coefficient is not 1, then we're going to apply this strategy that I haven't shown yet. And if these don't work, this doesn't work, prime. Not all polynomials are factorable. We hope they are, but they're not. Okay, ready? Good. The strategy for something like this is the following. We are looking to find 2 numbers such that the sum of these numbers that are unknown is, and the product is. Okay. The product is always this number, product, negative 20. And the sum is always this number, which is negative 1. So in the strategy in which a special product doesn't work and the leading coefficient is 1, I am looking for two numbers that fulfill both conditions at the same time. The numbers you'll give me, when you add them, you get negative 1. And the numbers you will give me, when you multiply them, you're going to get negative 20. Please follow me because this is very important, right here, right now. I start by looking at the product first, not at the sum. Why? Because the product tells me the sign of the numbers I'm looking for. So if the product is negative, then one of them has to be positive and one of them has to be negative. If the product is positive, both have to have the same sign. So let's stick with our first situation here. If the product of two numbers is negative, one must be positive and one must be negative. Do we agree with that? So positive and negative. So now, can we find two numbers, one positive and one negative, whose product is negative 20 and whose sum is negative 1? You cannot say 10 times 2. 10 times negative 2. The product is negative 20, but the sum is not negative 1. So can we find two numbers whose product is negative 20 and whose sum is negative 1? Yes, which one is positive, which one is negative? Yes, negative. You said negative 4?
Oh, negative 4.
Yes, because the sum has to be negative 1. So this is 4 and this is negative 5. The sum is negative 1, the product is negative 20. And these are the numbers I will be using to factor. So please tell me how to factor. X plus 4 and x minus 5. Let's check. I want to check my work. Is x times x squared? Is negative 5x but plus 4x negative x? And is positive 4 times negative 5 negative 20? Yes, you may have said, oh, special products are difficult. Everything else is more difficult than a special product. Trust me. It requires more work. If it's a special product, it's like that.
So is this not a special product?
Is x plus 4 times x minus 5 one of the special products?
But so you're saying number 6 on our sheet isn't a special product?
Nope,
What do you call it?
nothing. It's when a special product is not applicable and the trinomial has 1 as the leading coefficient. Then I have to follow these steps.
Okay, so it's kind of like a one-off. So
Yes, yes. It's a different situation, totally different.
Okay.
Very good. Next one. X squared plus 13x plus 36. Is this a trinomial?